Oops. Hello, welcome back. Can you hear me? Yep. Just to answer, I will start to type in an answer to you there, Kevin, as well. So yeah, it's so your question, Kevin, there is, would it not be better to test methods and behavior? So that's what you would be doing in the same situation. You would be testing the two together. So when you test behavior, by default, you'd be testing each of the methods. In some situations, it may be hard to test every path, to get full code coverage by only testing behavior. And in those situations, you could test methods in isolation as well, just to verify behavior and ensure full code coverage. Hope that answers. Does that answer that, Kevin, enough? Um, so the other questions I just answered there is as quick as I could there in the middle. Thanks, Dan. You can hear me perfect. Great. So the next set of slides is the right bicep. So a lot of this is going to be fairly self-explanatory for anyone who's done coding and stuff before. It's fairly self-explanatory. So it's just kind of making it into a kind of just making sure that it's putting it into basically an acronym to remember stuff. So it's essentially we have to understand what's important for us to test. And this right bicep acronym here helps us ask the right questions about what it is we want to test. So there's these guys here. So right, are the results right? Do we know what we mean by right and so on? So it's the biceps parts. The B for the bicep is making sure that our boundary conditions are correct. Can we check in using inverse relationships? We'll look at an example of that to verify tests, cross-checking results using other means, forcing errors to happen, and performance considerations as well, just looking at those. So it's just kind of a nice acronym to try and remember different bases that you should be looking at testing. So the key question, if we ran the code correctly, if the code ran correctly, how would the developer know? So it's generally a good idea to know what we're supposed to be developing. Otherwise, it's kind of hard to write proper code. So does it mean if we don't fully understand every single, if we don't fully understand what we mean in the code, I see people raising hands, is all okay? Mara, raise your hand. Is it sound or video, or is there anything? Is all okay? All okay, brilliant. Yeah, thank you. Lovely. So basically, this one here is, yes, we can continue writing our code. We don't have to stop until all the requirements are in. There's nothing to stop us to progressing up until we have answers to everything. We can keep going. We can use our best judgment and keep going on with that. And as we know as developers, that our requirements are constantly going to change. So we never fully know what we're doing sometimes. So the boundary conditions. So we're on to the B for the boundary conditions. And that correct there is another acronym as well to help you kind of figure out about boundary testing. So boundaries, most of our errors will exist at our boundaries. That's where the bugs generally live. So it's very important to do our boundary tests. And you might remember this guy from a few weeks ago where we started our first introduction to JUnit. We started, most of it was testing boundaries, wasn't it? We were testing when the largest number was in the first position, when it was in the last position, when there was only one. So we tested a lot of our boundaries using the kind of all of the test methods that we wrote there. So other examples, bogus input values, wrong file names, things like that, badly formatted data. So we've got an inconsistent email address, computations that result in numeric overflow can be quite annoying. Empty or missing values when we're expecting values, are we handling those ones? So these are what they consider boundaries to be tested. Values far in excess of reasonable expectations, an age of 150 years, so on. Duplicates and lists that shouldn't have duplicates. So testing things like kind of class attendance, there shouldn't be two people appearing as attended in the same class, the same person being down twice. ordered lists that aren't ordered, try handing a pre-sorted list to a sort algorithm, what happens? A reverse sorted list, what does it do? Does it completely and utterly take ages to sort it? So things that arrive out of order or happen out of expected order, try and print a document before logging in. So they're all different examples of what they consider boundaries for testing. Many more, as we all know, but that's just a small example there. So do you remember this guy I was showing you a few minutes ago? We looked at this one, the score collection, where it's just basically the responsibility of the score collection class was to maintain a list of scores, add of type scoreable, add items to it, and to calculate an arithmetic mean on those scores. So do you remember this very basic test here that we had? So we had our set up our collection object here. We add 5 to our collection object, our first location in the collection. Then we add 7 to it. So we've got two scores, 1 of 5, 1 of 7, using lambdas there. And what we do then is we invoke the arithmetic mean. We're acting on the SUT. We invoke arithmetic mean over our collection object, and we get a result. So, and then we're using our assert that. That was our new assertions that we were just looking at. We assert that the actual result, which is our system under test here, is equal to, that's our Hamcrest core matcher, and is equal to number 6. So do you remember looking at this guy? When we run it, okay, collection.add null. See what's going on here. Let's see what's happening in this one here. So we've got our score collection test. So what we've done is that runs fine. The very first method we were just looking at runs fine. But now what we started doing is we're trying to add a null into our collection. And we haven't catered for this. Our code was very basic. Do you remember it was really basic when we were looking at the actual store collection code? It was incredibly basic. So it's not going to throw in a legal argument exception for us. It's going to basically not be happy at all. Okay, and you can see down here, yeah. So I expected this illegal argument exception. We didn't get it. It added a null object for us. Okay, so what we do is we go back into our store collection, and what we do is we change it so that we are only going to be adding if it is not null. And we will throw this illegal argument exception here. So we've added in that code that's in the box there, reran again, and it's working now. So it throws an exception when adding a null is working for us. Okay, and then we add another test in, and we're dividing by 0. We all know that that does not work very well. We get your an arithmetic exception is thrown, program crashes unless we handle it. So collection.arithmetic mean, we're exercising our system here. We're saying it's equal to 0, and this is what happens here. Okay, we have no checks in our arithmetic mean method. We had no checks in to make sure that it wasn't going to stop it calculating and dividing by 0. So we had to put that check in and rerun our tests, and all is good. So these are all examples of your boundary testing. So, and the reason why we started looking at the boundary testing with you, with the max into, or with the largest, do you remember all of that largest? But now what we're doing is we're starting to look at it with bringing in lambdas with you, bringing in streams, bringing in extra Java 9, Java 8 constructs, just to get you used to these ones if you haven't any experience with them. Okay, so then we have dealing with integer overflow. What we're doing is we're adding in the max value for our integer in our new test. We're adding 1 on. So when we add the 2 of those guys together, integer overflow, yeah? So we're asserting that that should be our result, and it's not. So then what we do instead is our total here, what we're doing is we're putting it into a long. We're storing it in a long. So, and then what we're doing is we're recasting it back to an int to send back your arithmetic mean. So we're just using casting to sort out that error. Probably won't sort it in the full long run, depending on, you know, we might need to do a bit of a better job on that one. So boundary conditions. So one of the easiest ways to remember boundary conditions is by looking at the COR or ECT acronym. And Eamon's going to go through this with you. So Eamon will do the whole slide deck on these guys. So what we might do is just really scoot through these guys fast, Conformance, does the value conform to an expected format? Ordering, is the value ordered or unordered as appropriate? Reasonable minimum, maximum values, and so on. Eamon will go through all of those guys with you, and it's a way of remembering your boundary conditions of how to do your B and your bicep. So an inverse, can you check an inverse relationship? So this is another way of doing some tests as well. So sometimes you can do the logical inverse in order to be able to test something. So in this case here, what we're doing is, so we're testing square root using an inverse. So we're invoking our system under test here, my square root 4, and we're saying that this is the result. X is going to be the result. So what we're saying is that this 4, what we pass in would have been the squared value. And we're manually squaring it ourselves. And we're saying that the two of those should be equal to 4 within this tolerance level here. So we can do the opposite of what's happening to try and verify something. Okay. So another example of using an inverse relationship would be on a database. You can check that data was successfully inserted into a database by searching for it. Okay. So can you check by other means as well? So in this case here, we've written our own my square root method, and we're passing in a number, any old number, and root 1, that is the result of our square root method that we wrote. And then what we're doing is we're using a totally other means, another method, the maths one, the one that's belonged to Java, and we're doing their square root, and it's been put into this field here. And what we're doing then is we're comparing the two within a tolerance level. So probably one of the first questions you're going to say is, well, why would you write your own square root if there is one there? Maybe this is inefficient. Maybe there's some other reason. It could be too slow for production or something. It's just an example, but maybe it's a case of one of them might be too slow for production, but it's fine for doing it with your tests, to run your tests over it, to compare it against a slow performing one, but that will give you the right answer. Okay. So another example, a library database system, the number of copies of a particular book should also balance. So the number of copies that are checked out and the number of copies sitting on the shelves should always equal the total number of copies. So you can use different types of data like that to verify as well, cross-checking with other means. So like stock checking. So another one is, can you force error conditions to happen? A lot of different things will happen, like disks will fill up, network lines drop, and so on. So we can handle a fair few different things, handle a fair few error conditions, but it's not that easy to force some errors to happen. Like if the network goes down, you can't take down your work network to try and test your program and stuff. But there is ways of mocking stuff, and we will look at mocking later on as well, and doubling, stunt doubles and things like that. So things like if we're trying to simulate network outages, it can be quite difficult, but you will go through mocking with you and doubles, stunt doubles and things like that. So scenarios to consider when you're writing your forcing error conditions, they're all different ones that you can look at. So yeah. And then the last guy, performance characteristics. So does not necessarily mean measuring performance itself, but rather what you're interested in measuring is, as my data grows, or as my data sets grow, can my system handle the growth in data? Is it like, does the performance curve remain stable, basically? So that's something that you want to, it's generally not the actual magnitude of the performance you're interested in. It's making sure that the actual curve remains stable once you're happy with the performance with a small number of items running. Okay, so this guy here, we can look at, there's a URL filter here, so we can check against a small list. We're looking at the timer, elapsed time here. See that we're making sure that it's taken only a certain length of time when we compare against a small list and a large list and a medium list. Okay, so what we're doing is we're performance testing it here by manually coding it in ourselves. You can also look at this guy as well yourselves if you want to. It's kind of outside of the scope of what we're doing at the moment. But just in case you do want to look at this guy here, performance tools for performance management, if you're really interested. Yeah. So yeah, so it's basically what we're looking at is the so you need to basically provide a baseline information for making changes. So just say if you think that one of your methods is suboptimal, maybe we have implemented one of these guys here, a Java 8 Lambda oriented solution, and we don't think it's performing as well as the existing way that we used to code pre-Lambdas. So what you do is write a few performance tests that will capture the current elapsed time as a baseline, run it a few times, get your average, then change from that Lambda solution into the classic solution and compare again. And what you're doing is you're looking for relative improvements. The actual numbers, the magnitude of the numbers typically doesn't matter at the moment. What you're looking for is that there is a significant improvement in what it was running as. Okay, so that's just a really fast whistle-stop tour there of right bicep. A lot of that you probably would have been familiar with anyway as software developers and kind of your day-to-day testing and stuff, but it's just to put it into an acronym. And Eamon will continue on with a few more acronyms with you as well next week. So what we've left to do is the evolution of Java from 7 to 9. So I'm going to give you another little break as well, 5 minutes, and then we can start doing that. And if you have any questions, just type into the box there and I'll get back to you. So when we come back, we'll start looking at the language evolution Java.